Today, I want to talk about section 6.1, the inverse function. It's like outline. The first one, definition of a function. The definition of a one-to-one function. Definition of the inverse function. How to check if a function has the inverse function. So next one, I will explain how you can find the inverse function. The next one, how you can find the derivative of the inverse function. Like today's lecture, it's like outline. The first one, definition of a function. The function f is from A to B, is a relation that assigns to each element x in A exactly one element in B. So we have a name of A, that we call the domain of F, the B, the codomain of F, F of A, so this is the set of all function values f of x such that x is in the domain A. So we call the range of f, the range of f. This is one example. So this is a function 1R. Could you run your answer on the chatting board, please? This relation f is a function 1R. This is a function. This is a function. Could you write yes? This is not a function. Could you write no on the chatting board, please? This is f is a function 1R. What do you think? Could you run your answer? Yes. Yes. Here, f is a function. So because you can choose each element in A. You choose one. The one is go to exactly one number 4. The exactly one number 4. The 2 is going to exactly one number 6. The 3 is going to exactly one number 5. Yes, this is a function. This is a function. What's the domain? So could you write your answer on the chatting board? What is the domain of f? So could you write your answer on the chatting board? Domain of f is, do you know what the domain of f is? So do you know what the domain of f is? The 1 through 3, the 1, 2, 3, is it right? Yes, this is exactly 1, 2, 3. This is a whole A. This is a whole A. So exactly A, 1, 2, 3. What's the codomain of f? So could you run your answer on the chatting board? What is the codomain of f? Codomain of f is, do you know that? The 4 through 7, 4, 5, 6, 7, is it right? Yeah, this is right. Exactly. Whole B, 4, 5, 6, 7. What's the range? Could you run your answer on the chatting board? What is the range? The range is, what's the range? So do you know answer of range? The range of f? 4 through 6? Yes. Assigned number. 4, 5, 6. Assigned number. 4, 5, 6. The range of f. You can check this is a function 1. So what do you think? This is a function 1. This is a function. Could you write yes? This is not a function. Could you write no? So could you write your answer on the chatting board? This relation f is a function 1. So could you write your answer on the chatting board, please? Okay. Okay. Yeah, good, good. The participation is good. It's good. So what do you think? We are going back to definition. What's that? Assigned to each element x in A, exactly one element in B. So let me see. You can choose one element 1 is going to only one number, exactly one number 5. 2 is going to exactly one number 6. The 3 is going to exactly one number 5. It doesn't matter. Two different numbers are going to same number, but only one number is going to exactly one number. The 3 is going to exactly one number. Yes, this is a function. This is a function. What's the domain? So could you write your answer on the chatting board, please? So what is? Yeah, okay. You're right. This is a whole A. The whole A is domain. The codomain is for whole 4, 5, 6, 7, the B. The range is only assigned number, like a 5 and 6, only two numbers. What do you think? So this relation is a function or not? The same. Could you write your answer on the chatting board? Okay, good. So this is not a function because 1 is going to not exactly one number. 4 and 5. The 4 and 5. This is not a function because 1 is going to 4 and 5. The definition of a one-to-one function. The function f is called one-to-one function if it never takes on the same value twice. That is, f of x1 is not equal to f of x2 whenever x1 is not equal to x2. This is the exact definition of one-to-one function. You can check. This is a one-to-one or not. So what do you think? This function is a one-to-one? Or you check the f never takes on the same value twice. It's like exact definition. Answer is yes, one-to-one. So because f never takes on the same value twice. What do you think? So this function is a one-to-one or not? So could you run your answer? Okay. Okay. Yeah, not one-to-one, but because f takes on the same value twice. Here, 1 is going to 5, the 3 is going to same number 5. So f is a function, but not one-to-one, because f takes the same value 5 twice. Take the same value twice. We have one geometric method for checking if given graph is one-to-one or not. We call horizontal line test. Our function f is one-to-one function if and only if no horizontal line intersects each graph more than once. This is called horizontal line test. Here, the graph is black one is f is given. You can draw the red horizontal line. How many intersection points? We have 2 intersection points. What does it mean? So we have this one is like y values here. So we can draw the diagram. So what happens? x1, x2 are going to same value y twice. Is right? The f takes on the same value twice. This is not one-to-one. This is like the exact meaning of horizontal line test. You can draw a horizontal line. We have only one intersection point, no intersection point, one-to-one. So we have 2 intersection points, 3 intersection points, like more than once, not one-to-one, not one-to-one. It's called horizontal line test. So like this. I'm gonna check. What's that? f of x equals x squared is one-to-one or not? So could you run your answer on the chatting board? F of x equals x squared is no, no, no. Okay, yeah, thank you for your answering. Thank you. The f of x equals x squared is graph is parabola, is right? The graph is like parabola. This one, f of x. You can draw horizontal line. We have 2 intersection point. We have 2 intersection point. What does it mean? Not one-to-one. We have the two intersection point more than once, the not one-to-one, not one-to-one. What is g of x? G of x equals x cubed is one-to-one or not? Is one-to-one? Is right? One-to-one? What's the graph of g of x? The graph of g of x is like this. So g of x equals x cubed. Graph is this one. Here, this one. This is like g of x. You can draw any horizontal line. How many intersection point? Exactly one intersection point. Only one intersection point. What does it mean? The function is one-to-one. The one-to-one. This is the whole idea. Like this. The definition of inverse function. The f is a one-to-one function with the domain A, range B. Then its inverse function, we can use this notation of inverse function. This one has a domain B, range A. You have to change it. What's that? The function f has domain A. The inverse function has range A. Domain is going to range. So function f has range B. Inverse function has domain B. The range of B is going to domain of inverse function. It's defined by the inverse of f of y equals x. What's that? So this is same to f of x equals y. It's like exact meaning. So we have this one. X is going to y. By using f, we call f of x equals y. Y is going back to x. This is inverse of y is like x. So here was A. A is domain. The P is range. Was it like inverse function? The opposite. So this one is domain. This one is the range. Was it like exact meaning of inverse function? Only interchange the role of domain and the range, the input and the output. The input is going to output, output is going to input. This is exactly the definition of inverse function. We have one theorem. Function f is one-to-one. Inverse function always exists. The inverse of domain is same to range of f. Range of inverse is same to domain of f. The inverse of f of x is not 1 over f of x. Really be careful. This minus 1 is only notation of inverse. The minus 1 is not a power. The not a power minus 1. Not a power. So really be careful. So inverse of f of x is not equal to 1 over f of x. Don't write like this. We have a cancellation equation. Inverse of f of x equals x for every x in A. Inverse f of f of x is also f for every x in B. Here, this is already true. Why? You can use it. Here, x is going to f. This f of x is same to what? Y. You can change it, y. What's the inverse of y? Going backward again, going to x. X is going to y, going back to x again, exactly x. It's like a whole idea. Similarly, f of x is exactly x. This is always cancelled. Always cancelled. We call cancellation equations. Here, the AB was like an inverse relation. We can interchange the B and A. The 4 is going back to 1, 5 is going back to 3, 6 is going back to 2. We have this relation. The function f is 1-to-1. The inverse function exists. Was like A, domain of f is right here, exactly same to range of inverse. The P is range of f here, the exactly same to domain of inverse. Was it like inverse of f of 1? Here, the inverse of the f of 1 is here. 1 is going to 4. Inverse of 4 is here. 4 is going to 1 again. So what happens? So we have like this. Exactly cancelled. The cancellation equation works. This one, similar. The inverse of f of 4, the 4 is going to 1. What's f of 1? The 1 is going to 4. So we have this one, the cancelled. The cancellation equation works. So that's it. This is exactly the definition of inverse function. Here, function f is given. What do you think? Inverse function exists or not? So could you run your answer? Inverse function exists. Could you write yes? Inverse function does not exist. Could you write no? So what do you think? Inverse function exists or not? Yes, no. So what's your answers? Yeah. So write the answer. No. No. So here, the function f is not 1-to-1 because 1 and 2 are going to same number 4. So why here? Was it like an inverse relation? Going back. 4 is going back to 1. 4 is going back to 2. So like this. This is what? So 4 is going to 2 numbers, not a function. So inverse function does not exist. So we have one important remark. If function f is not 1-to-1, the inverse function does not exist. Inverse function does not exist. Function f is 1-to-1, inverse function exists. The function f is not 1-to-1, inverse function does not exist. This is one important result. Here, how can you find the inverse function of f? What's like the main things? You have to interchange input x, output y, only interchange. This is like the main part for finding inverse function. We have algebraic method. The step 1, write y equals f of x. Step 2, solve this equation for x in terms of y. Third one, interchange x and y. This is the whole idea. The resulting equation is y equals inverse of f of x. Yeah, this is the key. Third part, interchange x and y. What's like a geometric method? The graph of inverse of f is obtained by reflecting the graph of f about the line y equals x. Yeah, this is like it makes sense. Here, this is makes sense. Here, so we have one graph is given, so like this. Another one. This is y equals x. You can draw another one. This is a function f. This is the inverse function. It makes sense or not? You can choose this point. This point we have same length. So this point is like x, y. What's like this point? The y, x. So exactly interchange x and y. Yeah, this makes sense. The geometry method makes sense. Here, find the inverse function of f of x equals x squared plus 1. So what do you think? The first one, the inverse function exists or not? So could you run your answer on the chatting board? Inverse function exists or not? What do you think? The f of x equals x squared plus 1, inverse function exists or not? What do you think? No? No? The no, because the x squared plus 1 is like a black curve. You can draw horizontal line. How many intersection points? We have 2 intersection points. We have 2 intersection points. The f is not 1-to-1. What does it mean? Inverse function does not exist. Here, you can restrict domain. x is less than y equal to 0. Inverse function exists or not? What do you think? Inverse function exists? Yes or no? Yes. Inverse function exists? In this case, yes. Was it like f of x equals x squared plus 1? You can draw the graph. The graph is exactly parabola passing through 1. This is y-intercept. But domain is x is less than y equal to 0. Exactly like this. Only this portion. You can draw horizontal line. We have only one intersection point. Yes, this is a one-to-one. Inverse function exists here like this. By using horizontal line test, f is one-to-one. Inverse function exists. How can you find? I can follow step 1, step 2, step 3 from the algebraic method. Write y equals f of x. So we have, this is what? Y. Can you replace? This is just y. Y equals x squared plus 1. Step 2, solve this equation for x in terms of y. How can you do that? You can subtract 1 from both sides. So we have the x squared equals y minus 1. You can take a square root. X is the square root of y minus 1 or minus square root of y minus 1. So which one is x? Positive 1 or negative 1? So which one? Could you write your answer? So which one is the right answer? Positive 1, negative 1, or both? So which one? Positive 1? Positive 1 is like exactly x. Positive 1? Positive 1? Is it right? We are going back to domain. What's the domain? Domain is x is less than y equal to 0. X is what? The less than y equal to 0. The x is negative number. So don't choose here. So because x is less than or equal to 0, you can choose only negative 1. So domain is like this. X is greater than y equal to 0. Yes, you can choose a positive 1 depending on the domain of a function f. Domain of function f, only positive 1. Don't choose. Choose a negative 1. So like this. So step 3, interchange x and y. What does it mean? To replace x by y, y by x. We have y equals negative square root of x minus 1. So like this. This is inverse function. Was it like a geometric method for finding this one? The graph of inverse of f is obtained by reflecting the graph of f about y equals x. Here, you can draw y equals x. You have to reflect this graph about y equals x. The passing through 1 graph is like this one, right? This is only 1, this graph. This is symmetric about y equals x. This is the whole idea. So we have it. This red one is exactly inverse function. The inverse function. The next, find the inverse function of f of x equals 3x minus 5 over 2x plus 1. How can you do that? I'm going to use algebraic method. Step 1, write y equals f of x. You can replace f of x by just y. So like this. So step 2, solve this equation for x in terms of y. How can you do that? Just like a fraction, what's the best way? You have to multiply the both sides by denominator 2x plus 1. Crossed out, distribute y. So we have 2x here, 2xy plus y times 1 is y equals right hand side only 3x minus 5. So next, so we have 2x terms. Isolate 2x terms, subtract 2xy. Cancel. This side has 2x variable, but minus 5 doesn't have x. You can move to the right hand side, to the left hand side, sorry, here. So what happens? The right hand side is 3x minus 2xy equals, the left hand side is y plus 5. The next, the factor out x. 3 minus 2y equals y plus 5. The next, divide the both sides by coefficient of x, 3 minus 2y. So this is crossed out, x equals y plus 5 over 3 minus 2y, sorry, 3 minus 2y. So like this. This is like a whole idea for solving this problem, like this. Step 3, interchange x and y. What does it mean? Replace x by y, y by x. So that's it, so like this. This is inverse function. It's like a whole idea for finding inverse function from f of x equals 3x minus 5 over 2x plus 1. So next, the last one. How can you find derivative of the inverse function f, the inverse of f? We can use one theorem. If f is a one-to-one differentiable function with the inverse function inverse of f, so one more, f prime of inverse of f of a is not equal to 0, then the inverse function is differentiable at a. Inverse of f of prime of a is 1 over f prime of inverse of f of a. This is like a proof. Y equals inverse of f of x. You can use definition. Same to x equals f of y. Is right. This is the same. Only interchange some of the x and y and eliminate inverse sign. X equals f of y. The next, the take derivative with respect to x. So like this. Could you run your answer on the chatting board? What's x prime? Could you write what's x prime? Do you know what's x prime? Could you run your answer on the chatting board? What's x prime? Yep. You're right? Yes, 1, you're right. So do you know what's it like f of y prime? So could you run your answer on the chatting board? What is f of y prime? F of y prime is, do you know that? So we can use chain rule. It's like idea. F of g of x prime outer function prime of inner function times inner function prime. Exactly. Chain rule. What's like f of y prime? Here, the y is function. Y is a function, not variable. Exactly log of g of x. So outer function prime, so like this, times inner function prime. Exactly f prime of y times y prime. So we have it. So like this. So next, you can divide the both sides by f prime of y. Is cancelled. Y prime is 1 over f prime of y. The next, what's y? The y is inverse of f of x. You plug into here. You plug into here the inverse of x prime 1 over f prime of inverse of x. You can change this one. This is same to what? Inverse function prime of x. Same to this one. So like this. The next here. The replace x by a. You need to replace what? X by a. X by a. So we have it. So that's it. This is the whole idea. Inverse of f prime of a is 1 over f prime of inverse of f of a. This is like exact formula. It's a very important thing. It's very important formula. Here. So let me see. So when you use this kind of formulas, really be careful. What's that? The function f is one-to-one function. So in this case, we have this assumption. So f is one-to-one function, you can use a formula. F is not one-to-one, you cannot use. The first one, f of x equals 2x plus cosine of x is 1-to-1 or not. So could you write your answer on the chatting board, please? The 2x plus cosine of x is 1-to-1 or not. What do you think? What is your answer? So f of x equals 2x plus cosine of x. So this function is 1-to-1 or not. What do you think? Yes, this is 1-to-1. This is 1-to-1. Is right? This is 1-to-1. Yeah, this is 1-to-1. Yeah, this is 1-to-1. It's good. How can you know that? You can check f prime. You can take f prime of x. Because I will use the one good result in Math 140. What's that? F prime of x is positive number. What's like f? The function f is increasing. F prime of x is less than 0. The function f is decreasing. This is whole idea. So like this. You can take a derivative. Was it like a 2x prime? Could you run your answer on the chatting board? Was it 2x prime? Was it derivative of 2x? Yeah, only 2. It's good. Thanks. Was it cosine of x prime? So could you run your answer? Was it cosine x prime? Yeah, cosine x prime is, yeah, thank you, negative sine of x. I want to check. F prime is positive or negative. Do you know what's like minimum value of sine? The minimum value of sine is -1. The maximum value of sine is +1. Right? So like this. So sine function is between the -1 and 1. What's like the maximum? 1. 2 minus 1 is +1. The sine of x is like a minimum value -1. 2 minus -1 is +3. What does it mean? Always positive. F prime of x is always positive for all x. So f is increasing function. So do you know increasing function? The increasing function is the like this. You can draw a horizontal line. We have only one intersection point. What does it mean? The increasing function is always 1-to-1. The increasing function is always 1-to-1. So you can use this one. So we can follow 3 steps. Step 1. You need to find inside 1 inverse f of 1. You can calculate inverse f of 1. Step 2. the denominator, f prime of inverse of f of 1. Step 3, just reciprocal. The 1 over f prime, 1 over f prime of inverse of f of 1, like this. How can you find inverse of f of 1? Though we don't know, we can write x. Do you know this relation? Inverse of y equals x, exactly same to y equals f of x. You can use this relation here. What's the relation? 1 equals f of x. 1 equals the f of x is this one, 2x plus cosine. The next, you need to find x value. What's that? The 2x plus cosine of x is 1. What is x? Could you write your answer? How can you find? You cannot solve, only guess. Only guess number x. The which number satisfies 1 equals 2x plus cosine of x? Which number x? That satisfies the 2x plus cosine x equals 1. What do you think? What is x? Do you know what kind of x that satisfies 2x plus cosine of x equals 1? So which number? You can guess. Pi, 2. You can try these whole things. You can plug pi, the 1 equals 2 times x equals pi plus cosine of pi. The 1 equals 2 pi. Cosine pi is minus 1. You have to move 2 equals 2 pi. Oh, it doesn't make sense. Not an answer. You have 2, you can same thing. You can plug 2 into x. 1 equals 2 times 2 plus cosine of 2. The 1 equals 4 plus cosine of 2. The cosine of 2 is between minus 1 and 1. So smallest value is 3. The biggest value is 5. Doesn't match. We don't have it. You can plug 0. X equal to 0. 1 equals 2 times 0 plus cosine of 0. You can only check. The 2 times 0 is like 0. Do you know what is the cosine of 0? Do you know that? What's the cosine of 0? Yes. It's good. Yes. X is what? 0. You have it. X is 0. So what does it mean? We have one good result. You plug this x equal to 0 into here. The inverse of f of 1 is just 0. The second step, you can plug 0 into inside one, f prime of 0. How can you find f prime of 0? We already have f prime of x. Here, you can plug 0 into x. You can plug 0 into x, 2 minus sine of 0. Do you know sine of 0? Could you run your answer on the chatting board? What is sine of 0? Sine of 0 is, yep, 0. 2 minus 0 is only 2. The next step 3, what's that? The denominator is like 2. Only reciprocal of step 2. Answer is 1 over 2. But that's it. This is the whole idea for solving this problem. Always follow 3 steps. So I'm going to give one more example. Here, same. Check f is 1 to 1. F prime of x is this one prime. How can you calculate? Here, x cubed plus x squared plus x plus 1 to power 1/2 prime. Like this. Do you know this kind of channel? The g of x is like inside the power n prime. You can use chain rule. Power n is down. We have g of x to the power n minus 1 times g prime of x. You can use it. So what does it mean? The 1 over 2 is like a lower of n, the down. 1 over 2 x cubed plus 2x plus x plus 1 to the power 1 over 2 minus 1 times inner function x cubed plus 2x, sorry, this is x squared, not 2x, sorry about that. X squared plus x plus 1 prime. So this is 1 over 2 x cubed plus x squared plus x plus 1 to power negative 1/2 times x cubed prime 3x squared, x squared prime 2x, x prime is 1, 1 prime is 0. So we have it. So change it. So 1 over 2 times 1 over x cubed plus x squared plus x plus 1 to power 1/2 times 3x squared plus 2x plus 1. So numerator is 1 times 3x squared plus 2x plus 1 is 3x squared plus 2x plus 1 over bottom은 2 times square root of x cubed plus x squared plus x plus 1. So we have it. So we have this kind of things, exactly f prime of x. Don't like this. So what happens? This is a positive. You can draw the graph. This is always above x-axis, positive. The square root is always positive. So we have positive 1. The f is increasing and 1 to 1. So we can follow these steps. Step 1. You just only find inside 1 the inverse f of 2. You can find. Step 2. You can plug this one into denominator f prime of inverse of f of 2. Step 3. So you can use reciprocal 1 over f prime of inverse of f of 2. It's like a whole idea. The first one, inverse of f of 2 is we don't know right x. You can change it to the function f. How can you do that? The input 2 is going to output 2. Output x is going to input of a function f. One. So we have 2 equals. The f of x is here. The square root of x cubed plus x squared plus x plus 1. So we have it. So what is x? So could you write x on your chatting board, please? What is x? The which value satisfies 2 equals square root of x cubed plus x squared plus x plus 1. What is x? Is 1? Is it right? X is 1? X is 1? X is 1? Okay, you can try. You can plug 1 into x, exactly 2 equals square root of 1 cube plus 1 square plus 1 plus 1. 2 equals square root of 4. Yes. 2 equals to 2. It's good. Yes. X is 1. You have it. So what does it mean? You can plug 1 into here. We have this result. Inverse of f of 2 is just 1. You can plug this 1 into here. This inside 1, f prime of 1. F prime of x is given here. You plug 1 into x, so we have 3 times 1 squared plus 2 times 1 plus 1 over 2 times square root of 1 cube plus 1 square plus 1 plus 1. Top one is 3 plus 2 plus 1 is 6. 2 times the square root of 1 plus 1 plus 1 plus 1 is square root of 4. The square root of 4 is only 2. The 2 is crossed out, only 3. Answer is 3 over 2. This is not a final. The final answer is reciprocal. 1 over f prime of inverse of f of 2. Exactly the reciprocal of 3 over 2. Final answer is 2/3. So this is the whole idea for solving this problem. Okay. This is exactly the lecture like this. So this is all for the two-day lecture, the section, the 6.1. Do you have any question? So if you have any question, could you write your question on the chatting board? I will answer your question. If you don't have any more question, you can leave live session. The first one, thank you for attending my class. I appreciate. Thank you. And the one more, you just participate this class very well. Really appreciate. So you're welcome. Yeah, you're welcome. Okay, I'm waiting. You're welcome. If you have any question, you can write your question on the chatting board. If you don't have any question, you can leave live session. Yeah, the chain rule a little bit. I can do a little bit the chain rule here. We have one basic thing is f of g of x is given composite function prime. So we have exactly f prime outer function prime of inner function g of x times inner function prime. So we have it. So one example is sine of the x cube plus 1 prime. So in this case is sine function is log of f, x cube plus 1 is log of g of x. The first one, exactly the outer function prime. Outer function is sine prime. The sine prime is cosine of inner function x cube plus 1 times inner function prime x cube plus 1 prime. So we have cosine of x cube plus 1 times. So what is x cube plus 1 prime? X cube prime is 3x squared. The 1 prime is 0. So only rearrange 3x squared times cosine of x squared plus 1. So that's it. This is exactly one basic idea of chain rule. Another chain rule is this important thing, the g of x to the power n prime. This power n is log of f. So we have n is down by using power rule, n times inner function g of x to the power n minus 1 times g prime of x. The one example is square root of x squared plus 1 prime. How can you find the derivative? You can change the square root to only power form. Oh, so which one? Oh, x cube is right. Yes, this is x cube is right. What is x cube prime? X cube prime is exactly 3x squared. Yeah, this 3x squared. The 3x squared is, oh, yeah, right. Sorry, you're right. Yes, x cube. Don't miss. Thank you. Yeah, x cube. Don't change it. Yeah, thanks. So here, it's like a prime. 1 over 2 is like down, plus 1 to the power 1/2 minus 1 times the inner function x squared plus 1 prime. So like this. So we have 1 over 2 x squared plus 1 times minus 1/2 times x squared prime is only 2x, 1 prime 0. 2 is crossed out. So answer is x is going to top. So x squared plus 1 to the minus 1/2 back to denominator. Change radical form like this. This is like the basic idea of chain rule. Yep, it's like a chain rule. Do you have the more questions? It's good? Okay, you're welcome. So the more questions, you can write the question on the chatting board. I will answer your question. So if you don't have any more questions, you can leave live session. Yeah. You're welcome. That's good. Yep.